Hello everyone, my name is Isaac Kong. Today I'll be showing you my laser tag device that I have built. Now I'll tell you how the laser scoreboard works. This is an example of the detection. As you can see, when the device is being shot, the LEDs will light up and the sound. These are the components I used for the device. I used LEDs so that when the device is shot, the LEDs can light up, buttons to control the threshold, the buzzer to create a sound when it's being shot, LCD display to show how many times it's being shot and the threshold and the amount of light received, resistors so that I can resist electric current to protect some of the LEDs, and I use the Arduino as a microcontroller for all the components. So here's how I connected the LDR. So 5 volts will be used to power up the light dependent resistor. Then it will see how much light it receives and send a signal to pin A0 regarding the amount of light received. The other end will be connected to ground. This is the LED. Once the Arduino has sensed that the LDR is being shot by a laser beam, then an electric current from pin 7 will go and power up these 3 LEDs, and the other end will be connected to ground. So this is the buzzer module that I have used. Similarly, when it has been detected that the LDR has sent some amount of light, a signal will be sent to pin 9 so that it can make this buzzer module sound. The other end will be connected to ground. This is the button. Over here, there are 3 pins being used. The first one, when the button's being... So 3.3 volts will power up this button. When the button's being pressed, the signal will be sent to pin 8 for up button, pin 12 for down button, and pin 2 for the reset button. The other end of it will be connected to ground. Finally, this is the LCD display. First, a 5 volts power supply will be used to power up this. Then, it will be connected to VCC. The ground will be connected to the ground of the Arduino, and SCL and SDA, the 2 signal cables, will be connected to pin A4 and A5 respectively. So, now let me show you my code. This is the code that I have created. Over here, it tells the Arduino that the buzzer is at pin 9, the button reset is at pin 2, LED 7, the LDR will be A0, the score is 0, the threshold is 60 at first, the button up will be pin 8 and the button down will be pin 12. We imported these 2 modules to help us. When the Arduino is started, we will define everything over here, all the components, and the serial output will begin. Then, we will change the we will change LDR state when this is the loop, so that after the setup has finished, a loop will be created. Every time it loops, the LDR status will be sent to the analog read. The button status will be digital read from button reset. Up button will be digital read from button up, and down button will be digital read from button down. It's digital because buttons only require up or down, so it's either 1 or 0. So over here we tell the Arduino that if the reset button status is pressed, which is 1, the score will be set to 0. If the up button is increased by 1, which is when it's pressed 1, the threshold will be increased by 10. Similarly, if the down button is pressed when the status is 1, the threshold will minus 10. If the LDR status is lower than the threshold, then they will write to the LED pin low, meaning asking them not to light up. The LCD will initialize, the LCD's backlight will also start, and then they'll print all the statuses to the serial output. Over here we can see that they will print the head score, then they will print the threshold and the LDR. Else, if it's higher, then the LED pin will be set to high, meaning that the LED will light up, and then digital write the LED pin to be high again, so that it will blink sort of, and score will be increased by 1. Tone of buzzer will be done so that the buzzer will sound, it will wait, and then it will print everything again. After which, they will switch off the LED after delaying for 3 seconds, and then they'll print everything. So that's all for my code. I hope you have enjoyed my presentation. Thank you.